yeah, as you probably have seen, the kind of agenda for today was to continue the discussion on voting. There was really, if you're watching this recording later and you missed last week's, there was some really interesting discussion and ideas around voting discussed then. So this is just kind of carrying on that. And I think, yeah, Vivian had written up a nice document kind of summarizing some of the kind of stuff around voting. So I think we'll start with that. I've also put together a few slides on this kind of Centroid alternative approach, which isn't dramatically different, but just kind of a slight twist on what we're doing right now. I think it has some advantages, but also some issues that I think could be interesting to discuss. So I'm not convinced that that's the way, but it could be interesting to talk about. And then if we have time, we were going to go through a bit more of the kind of object behaviors, some of the open questions that, again, Vivian had kind of been bringing up last time in light of the new approach of separating out, yeah, the different models. And yeah, I can also comment on a couple things from when I watched the recording. But yeah, Vivian, do you want to start, or was there anything else anyone wants to kind of add to the sort of agenda? Otherwise, yeah.
Yeah, I'm happy to start.
Cool.
Yeah, so the first part of the document is actually just about reference frame transforms in general. So not even about voting yet, but since there were some misconceptions and misunderstandings around that, I thought it could be useful to like explicitly, to explicitly kind of draw out how it's working in Monty right now. And that's not to say that this is how we think it works in the brain. This is just to say this is how it's currently implemented. So we all have a common foundation when we talk about it. So I'll share my screen. Can you see this document?
Yeah.
Okay. So I think most of you have actually already read this. So I can go a bit faster on the first part. But feel free to interrupt and ask questions. So basically, we have the object placed in the world. That's in our experiment configs, for example, we specify the location of the object and where it should be rendered in our simulator. And that's not information that Monty ever gets. Monty doesn't know this, and Monty wants to infer this. And then we have features relative to the object. That's basically the definition of the mesh of the object to tell the simulator how to render it. Again, Monty doesn't know about this information, and Monty basically needs to learn how features are arranged relative to each other on objects.
I'm going to ask a very basic question right now, because you say relative to the world. What is the world? Is this an assumed reference frame for everything?
Yeah, it's just like a common reference frame. So concretely, for example, in Habitat Simulator, when you want to place an object in the environment, you have to specify it in XYZ coordinates of where you want to place it. And there's just one big XYZ reference frame.
Got it.
That you render everything.
In the real world, like the one biological organisms live, I don't think there is such a thing as a world reference frame. At least doesn't seem like
well, maybe not in the learning modules or in the brain, but
not even in the real world. I mean, I don't know. Is it my part of the world? It's all right.
Yeah, the world is.
I guess you could argue it's the location relative to the organism, or something like that.
Right.
I mean,
it's the ground truth location of the object relative to the organism.
I mean, I would argue it's basically where everything is in the universe. So, like, I mean, the world is likely not a simulation, so you probably don't have.
But the universe doesn't have any sort of, reference points. It's like we don't. There's no shared universal reference frame. I mean, what is it? Is the Earth at the center? Is it north, up, and down? I mean, I don't know. It's like.
Yeah, I mean, I'm not saying there's like one origin for the universe.
I just want to be clear. I think it's a made up concept, which is useful. I'm not against it. It's a made-up concept that doesn't really exist. I mean, you need it, you might need it to do rendering and habitat or something, but there is no there's no ground truth that exists in the universe.
Or,
'Cause
or maybe there's
Yeah.
like many ground truths. So it's like there's the location relative to the organism, there's the location of the mug relative to the table.
Right.
All of these are real.
I could say it's a location relative
And
to
at
my
any
house.
point, I guess we might be interested in one of them,
Yeah, okay,
or something
Right.
Yeah,
like
like
that.
everything has locations relative to other things in the world, and those are all
Right.
consistent with each other in a consistent metric space. There isn't
Right,
like,
but there is no world. There is no world reference frame. It's just, you could pick Earth, you could pick my house, you could pick, the sun, you could pick whatever you want as a basis, but there is no world reference frame. So it's just that term world, I guess we can assume for our simulations and for, a robot running around, we can assume that we're gonna assign some quote world reference frame, but it's not really the universe. It's like, there is no.
yeah, I guess I'm saying there's a metric space that everything is in, but where you set the origin is arbitrary.
Okay,
You just
right.
need something to describe the
Right.
relative locations of things in the
So,
world.
right. So it's undefined, but you could define it at any point in time.
Yeah,
Okay, so we're gonna assume we pick some world reference frame and then we're gonna work with that.
yeah. And again, this doesn't matter too much because this information is not available to Monty. So like if Monty is in a robot in the real world, I mean, we don't have to specify where objects are. They're
Right.
just there. So I guess in that case, there is no world reference frame, but still objects exist relative to each other in
Relative
locations
to the
and
right,
rotations. Yeah.
but not relative to the world. Okay.
Um, okay, so now then we get to the things that Monty actually knows about or tries to infer, which is it starts at the sensors. So we have sensor locations in a common reference frame. I call this relative to the world, but it could be relative to the body or something. It just needs to be a common reference frame of all sensors so that if one sensor moves, its displacement relative to the other sensors changes
Well,
consistently.
this got me confused because I said, well, how can the sensor be relative to the world? We don't know, what is the world? So if you say it's sensor relative to the body, that makes a lot more sense to me.
Yeah, I kind of switch between the two from time to time. I feel like relative to the body is more the way we talk about it in biology, but then it gets confusing once the body starts moving. So,
But we don't know the sensor relative to the world, right? We just know the sensor relative to the body. So
well, it's
my body doesn't know that necessarily. Okay, I found this really confusing, but I can shut up for a while.
I don't know if, yeah, I mean, I feel like with biology or kind of robots, we would talk about it generally kind of relative to the body, but it's kind of in Habitat, again, going back to like what Monty currently is doing, there is this kind of concept of
Okay,
a
so
world.
this is where I failed because I didn't, I'm not thinking habitat and the way they use that term. So and I
But
just
yeah,
kind
but if we
of
did, yeah.
I had trouble reading this. I really got confused and I kept thinking I should be able to understand this. But it's this terminology which perhaps I just don't share with everyone else. They got me confused.
Yeah, and then I guess with biology or robots or whatever, as well as it being relative to particular parts of the organism, whether that it's the head or whatever, it could also be relative to a fixed temporary point in the external world. So that's kind of where,
yeah,
you might anchor to a landmark in a room, like a
Yeah,
wall, or you might anchor to a corner of a screen.
right.
So at that point in time, all like a set of columns are going to use that reference point to describe locations.
yeah. So that's kind of more of how I'm thinking of it. That it's maybe it uses the grid cell place cell mechanism to also incorporate how the whole body moves in the current environment. So, for example, if I'm sensing this cup, it's kind of yes, I can move my finger on it, and that only changes the location of the sensor relative to the body. But I could also like actually walk around the cup And in that case, maybe I keep my finger fixed so the location of the sensor relative to the body is not changing, but my body is moving around in the environment. So I feel like that needs to be accounted for as well.
Absolutely. Right.
I think the only thing that really matters is that you keep track of, like, the world reference frame is fine even if it's just an orientation, because we only really care about the displacements.
Yeah. Yeah, right. That's another point. In a lot of cases, the absolute locations or like where you set the origin or anything like that doesn't matter at all. It's really mostly about the orientation.
Right.
Um,
Right.
Except for voting. And that's like, I feel one of the problems we were trying to resolve with this is if we could get voting to be non-bag of features, but not rely on each column or each learning module getting kind of like a concept of location of the sensor, then we could formulate pretty much the inputs and the outputs to each column, each learning module, purely in terms of movements and displacements. But right now we can't do that because then they lose any ability to communicate in a common language.
I have a question about that. You're talking about not having information about where the learning module is in the world, or like where its sensor is. But like, let's say you did want to clean a lens on your sensor, or you've got some kind of task that actually does involve the sensor's location in the world, and it's, it seems like it would have to be modeled somewhere.
Well, that's not the sensor's location in the world. That's to clean the lens, you have to know the sensor's location relative to the thing that's cleaning it, right? My other finger, isn't it?
well, yeah, I mean, right now
Hmm.
maybe it makes sense to go into that more with the figure on voting as a because yeah, so we do have the location of the sensor in the world, but it's more like the location of the sensor patch. That what you're getting at, Scott? That like we know where the camera is sensing in the world, but we don't know where the camera itself is.
Well, I was kind of thinking about cases where you do want to behave an action that affects the sensor itself. Maybe it does kind of make sense that a learning module, this is kind of an edge case, so maybe I can come back to it. But thinking about situations where we might actually want the learning module to know where in space the sensor that it's receiving from actually is
I guess I'm just
located.
wondering, right? I'm wondering whether kind of, I think along the lines of what Jeff was saying, because it's kind of, I guess, similar, even if we want an action to affect a location in space, like ultimately we want a location to be affected. But if we represent that location relative to us, like, oh, okay, this thing is so and so away from me, then we can specify the action also in terms of a relative movement. So if we know kind of where the, yeah, but I guess that is kind of an egocentric location. So
Yeah,
it's a bit, yeah, maybe circular.
we're diving deep into the philosophy about this right already. I've always felt like maybe this is worth sharing. I don't know. I've always felt like, oh, there's so many reference frames. Like even the body doesn't have a single reference frame. There's all different parts of the body. Which part of the body are we talking about? There is, and so I always felt like all you could do at any point in time is know the relative pose of two, let's say, learning modules or two things, and then that's so I can't say where my finger is relative to my body. I can say where my finger is relative to the tip of my nose, or where the finger is relative to my toe, or something like that. And so somehow this whole system has to work without having any kind of common reference frames for everything. It just feels like there isn't one. It can't be. There's no reference frame for the body. Even the eye, it's not. There's not a single point on the eye. There's lots of, it's curved and all this stuff going on, and it moves relative to the body. So I haven't worked this out. It's like there's no great answer here, but I've always felt like every time I think about a common reference frame that everything is relating to, I always felt like that doesn't seem possible. It seems like it's always going to be like point to point, and the brain is just constantly calculating like where my finger is to my nose, and then where my finger is to this, and where my finger is to the other finger of my eye. It just seems like it's a lot of little calculations as opposed to some sort of universal reference frame. That says, I don't know if that's useful, but I just throw that out because we're you know, and I guess probably for our simulator like Habitat, well, we have to have one. That's what they work with, right? So yeah, I get that. Anyway, I don't know. It's just the question is, do we really want to be working on universal reference frames? Is it always going to be column to column or learning module to learning module type of thing?
Yeah, maybe I'll walk through this real quick before we get too deep into the details, because I think the voting ultimately explains why we currently use a common reference frame for all the inputs.
Right, and that's, remember 2 weeks ago when I said I couldn't figure out how voting worked, because in essence I didn't assume there was a common reference frame, and then I
Yeah.
couldn't figure out how it worked.
But yeah, basically anything that's just internal to a learning module doesn't require a common reference frame. It just requires to know the displacement between two consecutive movements. So, which right now, since we're sending locations, that does require a common reference frame to calculate that. But yeah, if we were sending displacements, it wouldn't. Okay, but so basically we have the sensor's orientation relative to the world or relative to the body. And then we have the feature relative to the sensor. So that's basically if you get the depth image in the camera and then you calculate the point normal and curvature directions in that camera image, you get those directions relative to the image that you get. So that's the orientation relative to the sensor. But then we have this, in Monty it's called the depth to 3D transform, which basically combines the information from the depth image and the coordinates extracted from depth with the sensor's location in the world, so that we get locations and orientations of the feature in the world that's being sensed. And so that's this light green one, which basically corresponds to this one here. So it's the same. It's basically telling us what location and orientation is the sensor currently sensing in the world. And this is
And that's
what's
like a kind of a noisy estimate of the dark green one.
right.
So like
Yeah.
it's kind of
Yeah.
based on proprioception and depth estimation and all that kind of stuff.
Yeah. And this is what the learning module receives as an input. And this is kind of the main definition of the CMP right now, is that it always includes a location and an orientation in a common reference frame. And basically all of the messages that are being sent between sensor modules and learning modules are in that common reference frame. It could be any arbitrary origin, like it could be the body could be origin, some corner in the environment could be the origin, the roof could be the origin, but it just needs to have a common origin.
I mean, and it's beautiful you can do this, because it's always a mystery to me how, our eyes, we have no sense of what's on the retina at all. All we do is we perceive visual features at some distance and direction, and it's always been sort of a mystery. How does biology do that? And I mean, it's nice you've done that. You have to do that, but it's all these
Yeah, and I
problems.
guess I'm kind of I would maybe compare it a bit to spatial view cells that are basically active when you look at a specific location in the environment, and
Right.
they're independent of how your head is rotated, like independent of head direction cells, and independent of where you are standing in the room. They're just firing when you look at a specific location, like on the wall or on the table. And so I'm thinking of this as a similar thing, but it's, yeah.
Right,
Anyway,
right. That's exactly what I was just saying. Like that's what we see. We see things at some location in some reference
yeah,
frame and not on the sensor itself. And it's confusing in touch, by the way, because touch, we think of the touch sensors on your skin are actually on the surface. But then I've often talked about like, well, you can hold a tool in your hand and like that's like an inch extension from your fingers, and you can still touch with that. It's so it's like you don't get confused by that. Anyway, it's
Yeah.
great. I'm just it's nice that you've got it working.
Yeah, and yeah, I feel like since they do have evidence of those spatial view cells, it seems like the brain is somehow capable of representing locations in an environment that are being sensed by like the eyes in this instance, but it could also be like what the finger is touching through a glove or whatever. Um, and yeah, so we get these locations and orientations in a common reference frame, and those get sent to the learning module. And then this is where the inference happens. So we have a model that this learning module has learned, for instance, of the coffee cup. And that model is composed of features at locations. So we have locations in layer 6a, which I'm not showing explicitly here. And each location is associated with an orientation. And that's the orientation of the feature, not the orientation of the object. So this changes depending on where in the object's reference frame we are. Like if we're on the handle, we are sensing a different orientation relative to the object than if we're on the rim or on the outside of the mug or the inside of the mug. And then there's an overall orientation of the object relative to the model. So this is basically inferring how is the mug in the world that I'm currently sensing rotated relative to how my model is modeling the mug. And that's the orientation that's being applied to all of the inputs to this learning module. So in this case, the mug model and the object have the same orientation. Actually, yeah, I should go to this animation here. But if the object in the world actually changes its orientation, this orientation, the hypothesis orientation of the object relative to the model would change, which means we apply a different transform here. And since the mug is rotating, also the sensed feature is rotating with it. But since we have this transform and apply this object rotation to the incoming feature, this sensed feature at that location stays constant. So it's basically compensating for the object rotation so that we always get the same orientation at the same location on the object. And this is not shown here, but it would also be applied to any like movement displacements that the sensor is making that move us through the location space of the object. And I forgot to show this animation of the feature relative to the world. So since we have those two different orientations, one is the sensor relative to the world, one is the feature relative to the sensor. If we fixate on one point of the mug and the sensor moves while it's fixating on that point, while it moves, the orientation of the feature relative to the sensor, so the orientation like in the depth image of the point normal and curvature is changing, but it's changing regularly with how the sensor orientation is changing. So both of them together remain constant. The orientation of the feature in the world is not changing. We're just moving and looking at it from a different angle. We don't want this to change in that scenario. I know this is a lot to think through and even talk through. So yeah, are there any questions around this? Does that make sense to everyone?
Yeah, it's a beautiful animation too. I mean, I can just relate it to myself right now. I'm looking out a window, looking at a chair outside my house. And if I just move my head back and forth a little bit, it's like that moving thing in this animation. You know, I don't perceive anything about the chair and its features changing, right? That nothing out there seems to be changing at all, even though my head is moving. And I think it's a direct, you can just sit here and do this exact experiment right now. Just move your head while looking at something.
Yeah, exactly. Yeah, this mechanism basically makes sure that the input remains constant if we're changing the sensor orientation but still looking at the same location in the world. And then,
It's pretty
yeah,
unbelievable that all this stuff happens, actually. It's amazing.
yeah,
In real time.
yeah, it's pretty cool, and we just take it for granted. And I feel like a lot of AI doesn't even think about these problems much. So,
Right.
but we do it like
But when we're going to build
every second.
robots and moving things, these are absolutely essential. Everything here.
Yeah.
So,
Yeah, so we basically have these two mechanisms for compensating for different types of orientation changes. One is the sensor could be moving relative to the world, and that is compensated here in the sensor module. And then the second one is that the object could be moving in the world, and that is compensated by the learning module transform that's applied to the input features and movements.
so I love this. This is all great. But that compensation occurs in the sensor module. But again, biology doesn't matter too much always, but if I was thinking about vision in my head, where would that be occurring? I mean, you've got the retina, and that's got a lot of neural machinery, but then it goes right to the cortex. It goes to the thalamus and to the cortex. So where would this be? Where is this complicated thing happening? It seems like you wouldn't.
Yeah, I don't want to throw something out without checking the evidence for it. If I had to guess, like if I would have to just design it and put it in somewhere, I would probably have it just be applied in the thalamus as well. It's not a complicated change. It's just adding two transformations together. But
So that would be the only place it could occur, it seems. So and there's this again, what are these? These two signals are coming from where again? One is the feature relative to the sensor and the feature relative to the world. Those are no. What are the two things being added together?
these two yellow ones.
Sensor relative to the world and the feature relative to the sensor. Well, the feature relative to the sensor. Well, or actually, couldn't these be the extra layers in V1 doing this? Isn't that what we discussed before? Couldn't that also be where some of this is happening?
Yeah, I think that's something we talked about before, that those might be integrating kind of the depth information
Right.
into this.
All right, I'm happy with that. I'll leave it at that. Could be the thalamus, could be those extra layers and people, but it has to occur someplace.
Yeah, and it would have to occur quite early.
Right, and your argument is we want the learning module to not be thinking about this. The learning module shouldn't know about any of this, which is lovely.
Yeah.
It makes a nicer learning module. Just means this
I guess,
complexity has to be handled someplace.
is this another case where if we could do away with locations and we were just passing in displacements, then this would be simplified what pre-processing needs to be done.
I'm not sure. I mean, I feel like this, in my mind, this is like the main purpose of the sensor module is to convert all its like specific sensory input on all the pixels that change on the retina into a common language in a common reference frame. So I feel like that's in my mind the main purpose of the sensor module. And it's not a complicated transformation.
But when we say the sensor module in biology, it could also be the thalamus, you're saying. So it's just not the cortical columns themselves.
It could be, yeah.
Yeah, I guess I'm just wondering aloud whether, because I think we found some evidence, but also not like amazing evidence that it's like, okay, yeah, you have this kind of, for example, depth of a feature relative to the body and or the eye or whatever, available pre-cortically. And so maybe that's just a hint that we do need to somehow extract out this kind of global location and rely more on displacements.
I'm sympathetic with your idea that displacements are something like, if I think of it, displacements, that's something that neurons can transmit to each other, or I think of it like movement vectors, like you're moving this, at some speed in this direction. That's how I feel it, and you integrate over time in some sense. Whereas locations, if you think about locations, if the locations are specified using grid cells, I can't share that in biology. I can't, one learning module, one set of code can't send its representation to another person, because there's never any sort of common language between neurons, right? All you can do is association. You can do associative learning, like this pattern is associated with that pattern, or you can do, there's sort of a common, we're agreed on direction and then speed. It's just really puzzling. I mean, so displacements are nicer because I don't see how neurons can transmit locations, but locations seem to solve the problem. So I'm sympathetic with your comment, Niels.
Yeah, but I also don't have a great suggestion for how we get rid of that. So
Yeah.
I do have some stuff actually later on how maybe you could encode general location, like you say, in a way that can be shared, maybe. But it's
that'd be
definitely
nice to know. Yeah.
Yeah. I don't think it's
Okay, yeah, I'll try and wrap
solid.
up then so we
Okay.
can get to that.
Oh yeah,
Right.
So yeah, those are the general reference frame transformations happening in Monty. That's everything except for the voting transformations. So for voting, first of all, the setup is that we have at least two sensors that are sensing different points in space. So for example, here I'm showing two eyes that are sensing the rim and the handle of the mug. And each of those have the sensor location relative to the world and the feature relative to sensor. They get sent to the sensor module, combined into feature relative to the world. So this one would be sensing this location orientation, and this one would be sensing this location and orientation. And then, let me zoom out just a little bit. Those go into different learning modules. Same thing happens in the learning modules. We have the feature location relative to the world. We apply the hypothesized object orientation to it, and then that's the rotated input feature. Over some time, we develop hypotheses of where we are on the object. So that's indicated here with those red dots. This one is sensing the rim, so it has a couple of hypotheses of where it could be on the mug. All of them are on the rim, but it isn't sure where. This one would have hypotheses on the handle, for example, but I'm not showing that. And so this learning module would want to tell this one its hypotheses. So we take those points on the rim of the mug, and we also attach the feature in the world space or in the common space to that voting message, and we send it here to the other learning module. The other learning module takes that feature relative to world orientation, combine and calculates the difference of that to the feature it received, and it uses that difference to rotate all of the hypotheses into its reference frame, so that this way, in this case, we have like this one is actually over here on the rim, and this one is actually over here on the handle. So if we take those hypotheses, we rotate them and put them into this object's reference frame, only one of them actually is consistent with both. The one that's on the handle, most of the votes actually end up off of the object, like over here.
This
doesn't
kind
it
of vote.
use the orientation? Oh,
Go ahead, Niels.
I was to say, doesn't it use the orientations of the objects to do this transform? Because there's no reason that the local feature pose at one location is going to be consistent with the local feature pose at another location.
No, it doesn't use the object orientation because we assume that the object was learned in the same orientation. But basically the difference between these 2 points are how the sensors are displaced in space. So if this sensor is sensing over here, it can't just tell this learning module, oh, I think I'm somewhere here on the rim, because since this sensor is not sensing the same orientation, it shouldn't have hypotheses on the rim of the mug. It should have all of its hypotheses displaced by exactly this amount that the sensors are apart. So that's why we need to calculate the difference between those two and
So
apply it.
yeah, so we need the displacement,
Yeah.
and that needs to be correctly account for the relative orientation of the sensors. But that's just going to give us a new location to vote on. It's not giving us like a pose to vote on or anything.
We're not voting on pose right now.
Right. I guess yeah,
So,
I just wanted to make sure, yeah, that was clear, because I feel like yeah, maybe it was just me, but it sounded like that we were voting on pose, which I know we're not.
Yeah,
So-
no, yeah, I should clarify. So right now, we're not, oh yeah, go ahead.
what are we voting on? What would the language you use to describe it? We are voting on what?
So we send hypothesis-sized locations on this object's reference frame, translated into this object's reference frame, and that updates all of the hypotheses here. Each hypothesis is associated with an orientation
So
as
can I ask you a
well.
question? Is it going both directions at the same time?
Yeah,
And is it going, and how would this work between multiple learning modules? If I have 100 learning modules, how are they going, are we going through them serially, or how are we doing that?
no, it can all happen in parallel. So each of those learning modules would create a message like this, which is its hypothesized locations plus where its sensor is currently in space. And then the receiving learning modules can combine that information with where their sensor is currently in space.
But I
And
get a lot, I'm receiving 100 of these messages, let's say. So,
Yeah.
I mean, when I think of
so you
voting,
overlay a bunch of points onto your hypothesis space.
when I think about voting, I think it's like everyone is trying to come to an agreement about a single thing at this point in time. And I don't need to know anything at all about what the other people are thinking or whatever. I just say, here's my, this seems to me, I still don't understand how I could take 100 of these messages. It's like 100 messages I'm receiving. It's not like one thing. It's like 100 things, and I have to like handle them somehow. I mean, I'm just trying to, could this be neurally possible? I mean, could these all be on the same set of axons that are coming in and they're just all appearing, or these messages have to be kept
Yeah, I
separate?
don't think it's neurally plausible, not because of the amount of them, but because we need to apply those reference frame transformations to them, to all of them, different
Yeah.
transformations for different learning modules.
Yeah.
And those wouldn't be going through the thalamus. So I don't know
Well,
how that would
yeah.
happen.
Yeah, maybe this is a good segue actually into the slides I have on this. Yeah, there was
Might be. I
this-
guess I would just caution, the word voting means something to me now. And I think of it as we described it for voting on the ID. And that seems to be a much simpler and neurally realistic process. This is more of a message passing scheme. And which voting, as we've described before, is not really a message passing scheme, at least not in the biology. It's just it's just spreading activations and they settle. So it's using the word voting a little differently, I think, than we've used it in the past. That's tripping me up a bit. This is really
Yeah,
this is really message passing, right?
Yeah, so the main complication here is that we want a general solution that allows for sensors to move independently.
I understand.
If the sensors would always have the same offset to each other, then we could just have associative connections between the possible locations on the objects. We wouldn't have to do any.
That goes back to my earlier sort of proposal that perhaps locally on the cortical sheet cells do share have sort of a known,
Yeah, and I think, yeah, that could solve some problems. I think it would still be maybe a bit noisy in the case of like sensing different depth in neighboring columns.
yeah, it could be,
But
yeah. It's not
And even
perfect.
if the object is rotating in the world and stuff like that, I'm not sure it works because you don't have a fixed association between, oh, I'm at this location, you're at this
I
location.
know,
Because if
right, but
if the object starts rotating,
also, but I'm still in the camp that from a neuron point of view, none of this is possible, the way you've described it here. Which is not to say we shouldn't do it this way.
yeah, no,
Um,
I agree with you. I don't think this is possible.
Right,
At
so,
least not like with the layer 2-3 lateral connections, or I mean
yeah, right,
even layer 6B.
yeah, right. I
Don't see how they would do that.
I don't see how this works, but that's okay. It's okay for now. Niels is gonna give us some other thoughts about this.
Well, before you go on, can you go back? Because
Yeah,
I have some fundamental confusion by this graphic.
yeah.
Why are the rim hypotheses not mapped onto the rim of the model on the right?
Because basically this one says I think I'm here, but since you're not at the same place as I am, you should be over here. So this model should have its hypothesis on the rim because on the handle of the mug, because the sensor connected to this learning module. So basically the hypotheses are about where you think the sensor is on the object. And this sensor is somewhere else on the object than this sensor. So there isn't like one location on the object that they can all agree on.
Okay, I understand now. Yeah, my mental model was completely different, but I see how this works now. Thank you.
And I think Niels will maybe get into that, right now we're voting on location on the object. But if we were, for example, voting on the location of the object in the world, then they would both agree automatically, no matter where on the object each
Oh,
sensor
that
is.
sounds promising. That sounds good.
Yeah, I
Yeah,
like
that's
that
what I
idea too.
thought. That's why I thought we were doing this all the time. That's why I was so confused by this graphic. Okay, cool.
Yeah, no, maybe we can solve it very nicely with that idea, because yeah, this is quite complicated because we're basically translating between this object's reference frame to this object's reference frame directly without going through a common reference frame. And we have these sensor offsets. So yeah,
Is this what's implemented in Monty today, but it's in this diagram?
yeah.
Okay.
All right, Niels, I'll let you take
cool.
over.
Yeah, did you have any other questions, Tristan? Or okay.
Oh, yeah, sorry.
No, like once I saw where my understanding was wrong, I saw how it works now. So thank you.
I'm
Okay,
still
cool.
confused, Tristan. I'm glad you're not confused. I'm still confused.
Yeah, I wonder if there might be
Um,
like two ways to do this, or you might have to do it in two ways. Like if there are two sensors that are near each other, like in vision, and they know that they're near each other, then perhaps they can just learn the differences that they normally see, or the displacement that they have relative to each other can be kind of learned and kind of fixed. So in terms of translating a vote between modules that are connected to the same sensor, connected to the same agent, versus like these two fingers, they move relative to each other all the time. So that's going to it's just going to require more, maybe.
Right. I agree with you. Yeah, that's what I was leaning towards last time I talked about this. It's like, on the one hand, the two fingers seems to require this general purpose solution, but often, the pads on your fingers are next to each other and they sense things, and it doesn't require that universal solution.
Yeah.
And the eyes are, it's like all those things are arranged in an array. And yet, as Vivian points out, yeah, even though they're next to each other, or Niels pointed out, they don't always, they're not always observing even the same object. So you have to it's like, but it could be both, right? It could be both solutions. I think is what you're suggesting.
Yeah.
We have sort of a universal solution, and we also have like a local computation.
yeah, I guess the only thing with the local one is just like, I feel like it hits challenges even if you assume like fixed offsets. So it's like, okay, I don't know, I am seeing this, and I know that this other column is always to the right. So I'm going to somehow then predict that it should see that. But what if the model is oriented like this? I can't predict the same location.
Right. I agree. It has problems. But on the other hand,
But maybe it just works for upright objects, and that's why we're better at recognizing
I
upright
don't know. I
objects.
mean,
I don't know.
on the
Yeah.
other hand, it's like when I'm touching something, I made this observation is when I'm touching something with my finger, it's almost never just one part of my finger. You know, I bumped it, my following the edge of the cup, and then it bumps in, part of the finger bumps into the bottom of the handle. And it's not like, oh, I have two separate sensors. Where are they in the world? I'll have to figure out, where are they? No, they're right next to each other. My finger knows that there's now my finger itself is detecting a corner. It doesn't require anything else. It's like local to the finger computation. I mean, it just seems like, I don't have an answer. It doesn't work. But it just seems like you can make arguments in both cases, I guess.
Yeah.
It's weird. All right. But you're going to
Cool.
resolve this
So
all now.
yeah, I'll talk a bit. So yeah, a couple caveats. I think there are kind of issues or at least open questions with this, and I'm not as happy with the slides as I would like to have been, but hopefully it at least gives some kind of intuition that can help with the discussion. So, but yeah, this is basically this idea of kind of just having a common location or kind of like a more fixed location for each object, and that's what we're going to kind of vote on.
All
and
right. So
what the
you're saying
implications of
voting
that
on a
are.
common location of the object in the world? Is that what you mean?
I think it'll be clear
Okay.
when I show it. So yeah, so and thanks, Rami. I used your slides as a starting point. So yeah, so at the moment, we have in L6A kind of where we are on the object, whatever the kind of grid cells are active, represent that. And of course, that's kind of constantly changing, and so isn't a great substrate for kind of voting on. But then if you imagine somehow we develop kind of a fixed point, and we're going to treat that as kind of the location of the model or the object. And so that could be kind of the centroid, which is shown here as a gold point. And so in the kind of hypothesis, like if we think we're here on the stapler, the centroid thing is here. But if the hypothesis moves and we think we're here, the centroid is still the same. So within the LM, that's kind of fixed, independent of kind of where we're moving. And so, and that's all information internal to the learning module. So it can kind of determine where it currently is relative to the centroid.
And a nice thing about this is that as the sensor is moving over the object, this remains constant, whereas like your location on the object changes all the time. So it's not really ideal for voting.
Right, exactly. So exactly. So it's a stabler thing, which I think fits with what you were saying earlier, Jeff, about how voting should kind of happen with things that are stable.
Of course, we have to infer this centroid. We don't know it up front, right?
Yeah. So that's one of the issues. So, but yeah, and so if you have kind of two LMs, they each have their own model. Again, let's just assume for the moment, I'm just going to work through kind of the idea, and then we can talk about some of the issues. We just assume for the moment they both have centroids, and if those are using some inductive bias, they both have these points, and if they're using some inductive bias, like the center of the mass of the model or whatever, they might be similar. And so, if we have two fingers, they might be at different locations. This one's down here, this one's over here. And so, but in order for them to vote, it's not sufficient for these centroids to agree. As in, like, the centroids on their own aren't enough because we don't know where they are relative to each other. As in, if like this centroid is essentially constant, if that makes sense, as this moves, and this one's constant. So regardless of where the stapler is in the world, this centroid isn't telling us anything about how it agrees with another centroid. So another step is to factor in like where the centroid is in this kind of global shared coordinate system. So that's this kind of transformation from a more kind of allocentric representation to a more kind of global one. or at least kind of something that can be shared. But the kind of information we need for that is similar to, or is the same as kind of the information we need for our current version of voting. Like if we have the location of the sensor for each column in world coordinates, then we could do this transformation where we kind of say like, okay, the sensor's here relative to the sensor in our object model, the centroid's here. So relative to the world or the body or whatever, the centroid is here. And then that's going to happen in the other learning modules. And then that gives us a location representation that's both stable as we move, but also in this, and I'll get to an issue with this, in this setup, this location is common. It's the same here as it is here.
So are we voting on where the centroid is in the world? Is that what you're voting on?
Yeah. And so maybe a visualization of that is to show how this isn't kind of, this gets away from bag of features or whatever, is imagine the learning modules are sensing the same object like a T. So the feature in L4 here is this horizontal bar, and here it's this vertical bar. And we know where we're on the location of this vertical bar, or like we think we're here at least. And so the centroid relative to there is here. And then in this learning module, we think we're down here, and the centroid relative to there is here. And based on where our sensor is and where the centroid is, based on where the sensor is, based on where we think we are in the model, and based on where the centroid is relative to where we think we are in the model, we can calculate this centroid in a global space, and that can basically be compared. And that's where we'll see alignment. Those will be very similar. In contrast, oh yeah, and so in this example, the centroids, I don't know why that is off a bit. That's meant to be right here. In this example, this is where the sensors actually are. So the kind of hypotheses are correct, if you see what I mean. But just to show a counterexample, same input features, different arrangement. So this is where a bag of features would fail. Obviously, forgetting about cross features and stuff like that. So same thing, we think we're here on this local feature. We think we're here. So for the hypotheses that are questioning, oh, maybe we're on the cross, now they're going to vote. This learning module, its centroid is going to be here relative to this, and this learning module, its centroid is here. But because the sensors in the real world are here, and when we factor in those locations, you can see the locations of these kind of global centroids don't align. And so voting fails. Or if voting doesn't fail, voting correctly does not
and it's
recognize
supposed
a
to, in this
cross.
example, right? Like we're still sensing the T.
Yeah, exactly. We're sensing the T because, yeah, thank you. Yeah, so the locations of the sensors are here, and what they're actually sensing is this vertical bar and this horizontal bar, which you can see they're also sensing here, but they give different predictions, which is what, yeah, thank you. Any questions on that? So I guess then, so one clarification. So this common centroid, if we were to have it, I'd argue it's not used for hierarchy and compositionality. So this would be something, say, maybe in L5 that's used for voting. But we still have our location representation in L6, and that's the one that's used for compositionality that we bind on a location by location basis. So when we have compositionality, it's not that we are passing up, oh, this is where the logo is on the coffee, because like you said, Jeff, that was like an important step to move away from that. So I don't think this is kind of a step backwards in that sense, because it's just a different type of location representation. Here, it's about having a stable single representation that can be voted on. In terms of compositionality, we still want to use location by location associations. And so, yeah, I guess in terms of benefits, so I think we could implement this relatively easily in Monty. And I think the main reason we might consider that is just that it would be computationally more efficient in that each learning module just as we scale, Monty, because each learning module just needs to produce one centroid per object, rather than having these kinds of specific displacements for each pair of voting columns.
It would
So
require that different learning modules, who in some sense learn that they have to end up with the same location for the centroid. Right?
Yeah,
Which
which I agree
I think
is a mystery.
It's a really
or
the idea of a centroid is a really difficult thing to put your finger on and pin down.
Yeah.
There's lots of ways you could calculate a centroid, and you know, it's not isn't like this a simple thing.
Right. Yeah, and of course, each learning module might have slightly different models, and so
Right,
even if they're
right,
using
right,
kind of a
right.
common algorithm, they might end up with slightly different results and stuff.
Right,
Um,
right. And then as objects change, the centroids change, and you know,
Yeah, exactly. Yeah, I think that's one thing that I find particularly strange is that, yeah,
right.
like, you know, it's not like we get access to the whole model all at once and then, okay, great, we have a centroid. It's like we might
Right.
learn parts of it and then,
Yeah.
but yeah, I think it wouldn't be too, hard to implement, and that would at least be a benefit.
Why would it only produce one centroid per object? Wouldn't it still be one centroid per hypothesis?
Yeah, so the hypotheses could be different about where the centroid is, but each model would have one centroid.
Yeah, but it's still the same amount of votes that go out. They just contain different information. And
Yeah,
don't
the
need
same
to
amount
be
of votes, but
transformed.
they don't have to be recalculated for all the different pairs of LMs.
They don't have to be
So
transformed
if
into
one
the other reference frame. Like they don't have to be transformed in the other reference frame, but we still send the same amount of like locations.
we still send the same amount of votes, but like right now, if one learning module is going to send out to 3 different learning modules, it's going to have to do a different transformation, a different calculation for each one of those outgoing votes. Here, we just do it once and then we send it out.
Yeah, so I agree we save computation on the transformations. We don't have to transform the centroids anymore. But it's more than one centroid per object. It's still one centroid per hypothesis that we're sending out as votes.
Yeah, okay, I can clarify that here. So each LM produces per hypothesis.
Which, yeah, we can still threshold like we do right now, that we don't send all of the hypotheses as votes. But yeah.
Yeah. But yeah, it's just, I think, particularly as we scale more learning modules, then this is currently the calculation for the transformation is kind of an n squared calculation, whereas this one is linear in the number of hypotheses. And as you say, it's the same.
Yeah.
Yeah. Okay.
Oh, yes. So what you say, Jeff?
I didn't know if this is your last slide.
Okay, yeah. So one thing I was thinking was, does this actually work? Because I think this is a general issue with voting on locations, not just this proposal, but and this is very related to what you were just saying, Jeff, that locations, how do you share that? Because and how can that be reused? So imagine a stapler is at location XYZ relative to the body. So this gold point, it does all this stuff. It takes account of this location and it comes up with like a common egocentric representation of location. So, and that because it's neurons, let's say it's represented with SDR-A and this one with SDR-B. That's stable even as we kind of move around, because we're accounting for kind of where our sensor is and all this kind of stuff. As long as the object is in the same location in the environment, these are going to be the exact same. And so you can imagine them developing an associative connection. But if suddenly the stapler moves and it's now at a different location in relative to the body or the world, so XYZ prime, these are going to change because the transformation we're doing to account for where the sensor is relative to the body is going to give a totally different location of the stapler in the world. And so that's going to be a totally different neural representation in both of these. And so it's not clear how they can vote. So I
Yeah.
guess that's the issue. A kind of probably crazy and not true, maybe workaround would be a different coding scheme like oscillations or something,
Yeah.
where
Yeah.
if you have oscillation A and oscillation B are the same, then they're talking about the same kind of space. And so then you can imagine, okay, well, as long as there's some kind of universal algorithm for kind of how you are describing body centric coordinates with these oscillations, then even if we move to a totally different location, this will have oscillation, X, and this will have oscillation X, and they will agree. But that's, of course, who knows if that's possible. And I think, but I guess the only thing I thought was that might also maybe be interesting is that, this is where we have bursting. Maybe that's related. And then we were also talking about locations in the thalamus and how those might be universal in order to be communicated. And the thalamus
Well,
also has bursting.
we can sum this up saying, to get this work, we have to do a hell of a lot of speculative biology.
Yeah.
Okay.
Yeah, you
Yeah.
come up with this great simplifying proposal and then you ruin it with this problem.
Right. I had some thoughts listening to you, Neil. So I don't know if I wanted to wait till you're done before because it's.
Yeah, I think this is my last slide. So just, as we've talked about, okay, we need to learn, develop the centroids. How do we do that? And also, I just wanted to highlight this does not eliminate this kind of need to pass the locations of the sensors to each learning module. This is just what we were talking about before, that we were hoping to do this because firstly, it's not clear how this would happen in biology. And also that's kind of preventing us from moving to this kind of formulate everything as displacements. But yeah, that's everything.
Can you just bring up your picture again, the previous one?
Yeah, of course. This one,
Yeah,
or like one of these.
good. Yeah, that's good. If you don't mind, I'm just gonna jump in some thoughts on this.
Yeah.
It seems that at a very high level, we're constantly looking for something that columns are sharing that is not specific to the object necessarily. It's like, I mean, even the centroid is like that. The centroid really isn't object specific. It's sort of blobby morphology specific, right? The centroid's not going to move if I have a stapler of some shape, and then I also have a banana in the same shape in this space. And so it seems like for this, to get around this, bag of features concept, that two learning modules or n learning modules, they must be referring to something else that's not object specific, that's shared. Okay, it could be the body's reference frame. It could be the centroid. It could be something. But it just seems that it has to be something common that they all know about and they agree about. I'm not a fan of the centroid for various reasons. I think it's going to be impact, but it's a way good thinking about it. Because I think it's going to be hard to do, and I don't know how the neurons could do that.
Right.
All this research you just brought up. I'm going to go back to an observation I had earlier, which might be a clue to the answer. I had this observation not today, but at a previous time, that even if I'm not touching something, and if my hands are in some position relative to my body, like I'm my two hands, I'm holding my hands out here, I have a sense of the confining space that they're occupying. That if I'm about to touch something, I don't know what I don't know what it is. My hands are coming together like this. And even if they touch something, I don't know what it is. I've defined even I have absolutely no hypothesis of what I'm touching, but I have defined a space that thing occupies. So I mean, maybe there's a whole bunch of things that are like relative to this coffee cup. I can't tell them what, but as soon as I touch several points, even just 2 or 3, I'm constraining the space that I perceive that's objects independent. It has nothing to do with the object. I mean, it has nothing to do with the specific object. It has to do with somehow the morphology of the object. And so there's this there's almost like a morphology sort of model that's not object specific. And that sort of exists somehow because of where my fingers are relative to each other. And so it's a little bit like the centroid, but it's not the centroid. It's a morphology sort centroid. You know what I'm saying? It's like this is the constraint morphology of the object, and even if I don't know what I'm touching at this point in time, if I know if I move my finger around to the other side, I know where it's going to touch the object over here, where it's likely to touch the object over here, because I already built up this model. It'd be like also
Yeah, so as in it's almost like they're voting on like a volume or something, or
right. It's a model, which is sort of like a morphology, but it's not an object specific morphology.
Could it be that the columns that are modeling the coffee mug as you grasp it aren't actually voting on locations, but instead, kind of like you said, somewhere else you have a model of this rough space that your hand can enclose, and that
Right.
can kind of bias your coffee mug models to become active because it has that space. Because I'm not sure, like we need to do the Olympics again with like just flash inference with the hand, because I feel like, yeah, with a mug, you think, okay, yeah, I can tell that. But this is something you grasp all the time and it's just a cylindrical object. For example, something just slightly more complex, like this ringing heart. If I grasp it like this or like this, I don't think I would actually be able to tell it's a heart shape.
Right.
Like even if I get the outlines of it, it would be very difficult. I would have to like mentally imagine it and have like a mental picture of it. And
This is
then
an interesting question. So as we think about this thing, the next thing that comes to my mind, I said, is this sense that I'm enclosing some volume, whether it's the cup or the heart or something, is it something I had to learn? Did I learn a sense of sort of morphological volumes that are independent of objects? I mean, I don't like this point, but it's an interesting question. As a child, did I have to practice to understand volumetric spaces, to learn that? Is there a set of morphology models that are independent of objects that are sort of learned egocentrically or something? Well, just learned independently of them. And so I don't know how to phrase this, but I really, really don't want to go down to point by point, sharing points. It just doesn't, neurons don't do that.
yeah, I mean,
yeah, I think it is interesting though, because or maybe a related thing is just that when we interact with objects, often the specific identity or whatever doesn't matter as much as the shape, like when we pick things up. So as in like whether we're picking up like a can or
right. I don't need to
a
know
mug or whatever, it doesn't really matter.
Is it a can of beans or a can of green beans? It doesn't really matter.
It's more the general shape.
And we get back to our question of classes. We've always had this question about classes of objects, and what defines a class of an object? Well, it's probably morphology and behaviors more than specific details. And anyway, so we've been bouncing around these similar ideas that have just been very confusing. And I'm going back to, like, to solve this particular problem we're trying to solve, I feel like I want to do it in the way we solve the compositional object problem, which is you somehow do it on a point-by-point basis, not on some sort of passing locations, and we don't assume there's a centroid, because the centroid is really hard to put your finger on what the hell that is. Right? And so I'm just wondering. I don't have an answer here. I just feel like there's sort of like there's sort of a ability to recognize volumetric spaces independent of what the actual object is. And if I know what the object is, it can help me recognize volumetric space. If I know the volumetric space, I can recognize the object. This goes back to maybe Vivian was breaking down morphology from feature objects, morphology object and feature object.
Yeah, it could be maybe that you have a model of your hand somewhere, and your hand can be in different states. And if your hand is in a certain state like this, that biases cylindrical objects or something. But the cylindrical objects themselves don't take into account the relative displacements of the fingers and vote on it. They just vote on object ID perhaps, and not on locations. And I know we don't want to have bag of features, but we already have very structured inference through movement. So maybe it's just not something we can do very well to do like
Right.
structured inference with flash inference.
Well, that's why, and I made that point 2 weeks ago, and then or a week ago, and then I said, but with vision we can do it, you know, and yet how? I made that observation. I think with touch it's really hard to do it. If you just have a few points, it's like I have to really kind of move, you know. But with vision, and I show those examples, we do it, and then that's where I came back to say, well, you know, are we taking advantage of the fact that the retina has an array and the features are next to each other? I
Right.
don't know.
Yeah, and
but-
I was thinking last week while I was watching the presentation, just that like, because there was a lot of discussion about voting on rotation, and that does reduce some of the bag of featureness. Like, I think we're all happy how we could vote on rotation of the object. And so you can imagine, like, if you have a scrambled face, say, if the orientation of the lips and the eyes and all that is kind of crazy, those local features aren't going to agree on the orientation of the face. And so they're not going to agree that there's a face. If the orientations are all correct, as they would be on a face, and they're just moved location-wise, then rotation isn't helpful as a voting thing to prevent bag of
Right.
features. But then that might again go back to what you and Scott and were saying, that like, okay, maybe it's a local thing, and as long as we can do it kind of in some senses, some cases like upright, kind of like you're saying, Vivian, maybe we don't do flash inference well for everything, or like structurally. And then I guess the last question is, we have a mechanism for avoiding bag of features. Is this a case where we want to avoid, like, we can kind of Monty can do flash inference almost with an object. So is it now superhuman?
Yeah.
And maybe that's not a
Right.
bad thing.
Right. Hoji, did you want to ask or say something?
Yeah, I guess I just had a potential another idea to like solve this kind of like location problem. I don't know if it's kind of cheating, but at least in like robotics, when we want to like determine, like we don't, I think earlier in our discussion we kind of agree that like we don't really have like a universal or world reference frame, and one way to just provide that is to have the object with like a fiducial marker. So like if and just we just agree that if we see that fiducial marker, that's just the origin.
What,
Fiducial
sorry?
marker being like a unique feature that once you locate it, you know everything.
Yeah,
Right.
so the RUCO tags that we have used in like our drone project, that is like used like, so if you see that like QR code, basically like we can introduce that like inside Monty,
But
and
what would be the equivalent here? We can't add these things to the objects in the world, can we?
not the objects, but I mean kind of like in the general like habitat world. We basically we're ignoring the simulator's coordinates. So let's say we have an object on habitat and also this marker and habitat, like whenever the sensors move around and see the fiducial or RUCO tag or
So
QR,
you're
then
saying
we just
have something that uniquely specifies where you are in space relative to where anchoring space. Is that what it does?
yeah, basically we're providing the coordinate system in some sense, so we can still go on to use the
What
like
is that to solve the like the where we get a global coordinate system from, or
yeah. So
Well,
I don't think
yeah,
we need
well,
to
but
solve that because it doesn't matter where the origin is. We can just set the origin at the first observation, and like we can set it arbitrarily. It doesn't have to always be the
yeah.
same thing or anything. So I'm not sure if we would have to wait for finding a unique feature to set it to that.
yeah, in
Yeah,
terms of
but
like
I guess if
analogy
there's
to the
like a
brain, it feels like I
there's no
mean,
analogy to the brain. It's just like we're
well, I
basically
mean,
looking at something and deciding, okay, like I don't have a like perfect
but we
location
do
for
visually anchor to things. So
yeah.
like in a fully developed intelligent brain, it might visually anchor to like the sofa or whatever. And so until that's developed, I guess you could use something like this. But yeah, I agree with Vivian. I don't think it's really a problem. And if we're going to cheat anyways, it's also not a problem that we just have habitats global
Yeah.
coordinates.
Yeah.
Cheat. Well, why don't we put a label on it telling you what the object is? So we're good. We put a little mark on every object. Well,
Yeah. I
it's
mean, I
interesting
guess
to think about.
the difference is that instead of like being relied on habitat, like it's something that we can learn. I guess that's the only kind of like, difference.
Yeah.
Instead of relying on like whatever coordinate system that habitat gives us. But yeah, anyways, yeah, that
We
was
don't
just
have to use habitat's coordinate system. We could start with like the first observation, just set that to 0, completely ignore what that actual location is, and
yeah,
just use every movement after that to calculate the relative location from the starting point. Like
yeah, and
we
that
don't have to
yeah.
use the origin from habitat.
Some, as I've said many times, sometimes, we're at the point where some things we don't really have to do it. Biology does it, and that's fine. As long as we stick to the principles. I'm not sure this is one of those. It strikes me just a moment ago, we were talking about, oh yeah, like said, you can pick up an object, not know the specific object, but still know what to do with it. Like, oh, it's just a can or it's a bottle or something. I don't know, whatever it is, or this is a cap and I can unscrew it. Seems pretty fundamental sort of capability to be able to do those kind of things. So I feel a little bit more that we should delve into this further. I don't want to give up on this one yet. I like the idea of just not avoiding setting points. It seems like we have trouble that, but I also like the idea that we could somehow develop a morphology model that's independent of the object, and or it's maybe we temporarily build it even like I'm just imagining this idea that I'm touching something, and now even if I stop touching it, I still perceive that I still have this impression that it's there, and I know my finger and I move it around and I touch on the other side, I expect to feel it, even I have no idea what the object is. I just know that there's something occupying some space in the world, and it's temporarily at some place relative to my body, but it's absolutely located relative to my fingers. So it's not like, oh, this is a model of a morphology object that's in front of me or ahead of me. It's more like just somehow we temporarily build this morphology model of space in space, and then I know where my fingers are relative to each other, even though I don't know what the object is. And somehow that knowledge is already there. I haven't started voting yet. There's no voting going on. It's just somehow, or at least I'm voting on shape and space, not on a particular object necessarily. I'm just speaking randomly here. I feel like
Would you be
close to a
modeling the space between your fingers, or modeling the shape of your hand?
It's less about the shape of my hand. It's like that mime, in the box. It's like you see the box. You don't really care with it. At any point in time, the hand moves. Imagine there's this box there because you watch this mime touching it, right? It's like that yourself. You're just like you're doing the mime thing, except around some. At any point in time, when my fingers, if I say this is, I'm touching something, or I touch, I'm building up this sort of volumetric space. I don't know what to do with it yet.
Yeah.
That feels like that is somehow the substrate at which we solve this problem. I don't think it's a centroid. I don't think it's a point in a reference frame. It could be a shape in a reference frame. It could be okay. We have a reference frame where that's common somehow, but it's involving but it's not an object specific one. I don't have an answer to it. I feel like the answer needs to involve that idea. That's what it feels
Could it
like.
almost be a bit like, if it's not a model, that the feature we're actually feeling is this kind of volume. So as in the same way that the color red or whatever is just extracted, or lines are just extracted, and those are the input features, the like volume itself, or the kind of feeling of something being in between your fingers, that's more of a feature than an actual model.
But it's really just a pure sort of edge feature. It's a, you know, it doesn't say anything about, you know,
Well, I guess I'm wondering whether that's one thing, as in like each finger pad is sensing just a feature, but is the hand, I don't know, somehow
Like-
picking up like a more global feature in the same way that like, I don't know, maybe a retinal patch that gets a large input sees like, okay, there's a dark blur where there's a head. It's like, what is the equivalent of like a larger, more global tactile feature rather than just being a little thing sensed on a finger pad? Maybe it's this feeling of like a solid
know.
thing.
I don't know.
Right.
I feel like we'll get to Jose's question in a second here. It feels to me like we don't want it to have big blurry features. It's more like, no, we have features, they can be large or small, but we still have an assemblage of them to create some volume and object. And so if I have larger or smaller features, it doesn't really, I don't think that changes the nature of the problem. I think, I don't know if someone wants to take a stab at Jose's question, but I can do it. Jose, we start out with the idea that every learning module is able to learn objects and infer objects by movement, right? And so that's great, and it works really well. And then we said, okay, but we have this idea of flash inference, which is in vision, you don't have to move your eyes at all, and you can still recognize it. And so each learning module, you might have multiple learning modules looking at the object, but each one doesn't, on their own, they don't have enough information to infer the object. They have to know where they are relative to each other. And that's the only way you can do flash inference, is that the different learning modules each sense a little feature, but they have to somehow integrate it and say, oh yeah, well, given where your feature is and my feature is and so on, then we can recognize the object. But we have no way of, how does the learning module know where all the other features are that are being detected by other learning modules? And so that's the problem. And if you don't have that, it's just a bag of features. Does that make sense, Jose?
Yeah, but um,
No, because it doesn't. Okay, that's all right.
well, if we have a global coordinate system, then this wouldn't.
Well,
Well,
but imagine you're a learning module and you get one feature at some point in space,
Yeah.
right? Well, fine. If I have a global coordinate system, then someone could look down and say, hey, look, all these other guys found these different features at different points in space. Now we have enough information. But how does that get transmitted to the learning module? The fact that there's 100 other modules at different points in space, and how's that going to change me? How's that going to tell me what to do? How do I incorporate it into some meaningful way? That's the problem. That's how I view the problem. I don't know if
Can
that's
it come from center module?
but there's still a question of,
But each learning module doesn't get all of the locations as input at once. Each learning module just gets one of those locations. And then if it wants to integrate multiple locations at the same time step without moving, it needs to vote with other learning modules that received other points in space as input. So the question is then, how would this voting work, given that each learning module has its own reference frame, its own unique location space for this object? How could those unique object location spaces vote with each other? Especially also given that the location on the object is different for each of the learning modules and changes with every movement of the sensor.
imagine you have 100 sensors sensing an object, and each one, and each one knows where they are in some relative to some global coordinate system. Let's say that, okay? So the information is there. The information we need is there. It's like, oh, there's a feature at some location around, some global coordinate system. So all the information we have to solve this problem is available. The question is, how does it get around? How do you integrate it? There's no master genie looking at all the stuff and totaling it all up and making a picture and drawing it out or something like that. These learning modules are kind of stupid And it says, oh, I know a feature at some location in space, but how am I supposed to know what everyone else is doing? You know, who's masterminding this whole thing? You know, that's part of the question. That's, I think, the question.
But
Yeah,
like,
I mean, I guess the thing is that the LM has their each unique reference frames. Can it, is it too much to ask for LMs to like share the same reference frame or something?
Well, even if they did, which seems biologically unlikely, but even if they did, I still have a communications problem.
Yeah,
I
that's
still have
what
an
they
issue.
currently do in Monty. Basically,
Yeah,
we assume that they learned the object in the same location and orientation, so their model reference frames line up. So then we only have to compensate for the sensors being in different
right,
locations on the object.
So only
right.
compensate for that. It doesn't,
Yeah.
that doesn't eliminate that challenge.
Well, I'm a little bit confused about our current implementation. I'm still confused. Does it work well or does it not work well? I mean, does it have problems or not have problems?
No, it works well. I mean,
Does it
it's
have-
just not super efficient because, I mean, it's not slowing it down too much, but it's about as
What's
many transformations as you would do if you have one learning module just moving that amount of steps.
what's the slow part actually? Exactly.
The slowest part is the nearest neighbor search, where we basically we get a location hypothesis, and then we need to search what points are near in the receiving hypothesis space. But that's a bit irrelevant with the voting mechanism. That's a general problem with both voting and the movement mechanism.
I'm not following that. I don't know if I need to, but I'm not following it. I actually didn't follow exactly how Monty does this, you know, where you know, the little dots you're moving around in the cup. I just kept struggling with that thing. Like, I got a whole bunch of these things coming in at once. What do I do about them? You know? Yeah, and just
But
I
yeah,
have a question.
yeah.
Like on Retina, right? Like with vision, it's fixed. Like learning modules are fixed relative to each other, the ones that perceive Retina input. So, and then people who receive vision later in life, they don't perceive vision, right? Because, so could it be that the learning modules never learned their relative positions during the formation or whatnot? And the question is regarding voting, like, what if we just assume that learning modules know exactly the relative offset of whatever input's coming in local space, right? In Retina, it's all local, it's all fixed, it never changes, so that could be learned. Just going back to the, you know, it's both, there's a global and the local thing, but vision is a huge fixed reference frame that's just
right.
overwhelming. So like I struggle to see how they cannot learn the relative placement of what they're
Right,
seeing.
right. Well, then that's why we start talking immediately. Go start saying, okay, well, what's the equivalent in touch, right? Because you know the idea that well, your hands are moving relative to each other quite dramatically, and so I just had a thought, so I'm slowing down because I'm thinking about something. And so, you know, the preamble to my talk last time I talked about this was this issue. Like, yeah, well, vision is confusing because all the retinal patches are in fixed relationship to each other. They're a fixed relationship on the retina. They're not fixed relationship on the objects, right? Because again, one retinal patch could be on an object in the distance, another retinal patch looking at one that's closer to you. So there's not always fixed relationship in the world between what two retinal patches are sensing. But there's often there is. So that seemed like, yeah, a big clue there. I agree with you, Tristan. That could really be a big part of it. But then we started talking about touch, and it's like, well, that doesn't seem right. And then I made the argument, well, along the skin or along an area of your skin, some small area, there's a lot of sensory patches that are in relationship to each other. Like the top digit of my finger, that's pretty fixed, just like the retina. And so, and these could be learned. Anything that's touching different parts of my fingertip could be learned just like the retina could be learned. And so, you know, this part of my finger and this part of my finger are always going to be in the same relationship to each other. So we're struggling with that, right? On the other hand, you can judge things with two fingers and it seems to work somewhat. I don't know. So, that was the Olympics, but maybe it doesn't work as well as we think it works.
Yeah, maybe it is just that we can really just do it with sensors that have a relatively fixed arrangement. I mean, with vision, you still have depth, but you can still do estimations, even if you don't take into account depth. So maybe that's why the flash inference works with the scenes that you showed the other day, Jeff. But then it might just not be something we can do for arbitrary objects with like our fingers, multiple fingers, just
Well,
recognizing them with touch.
I should do a hole in our theory that and we haven't really addressed is that learn an object with, say, a set of sensors, and then I can infer the object with a completely different. Touch and vision and for right hand. Learn multiple today it's like, okay, I got a single finger I'm touching, or just got a vision, I'm learning it. But in reality, we must learn models at the same time that are independent of specific modalities. And this could relate, I never really thought about this too much, other than saying, oh, it's a big hole, we have to address it sometime. But it gets back to maybe this idea that you're defining some sort of morphological shape in the world. And you can do that with any sensor, like any part of your skin, back of my hand, front of my hand, doesn't really matter. So it's somehow like any part, any sensor on my skin I can know where it is in the world, I have that knowledge, let's say. And then I can start building up this morphological model, not in the skin sensor patch, but somewhere else. It has to be somewhere else. The modules that represent the tip of my finger and the learning modules that represent the back of my hand, the one in the back of my hand can't recognize, it doesn't know anything about cups. So there has to be someplace else where the cups are learned, where I could then infer the cup with the back of my hand. You know what I'm saying?
Yeah, I feel like maybe a few months ago we kind of talked a bit about this, and at least I feel like hierarchy, and we talked about that, is like a decent solution to this, where like if you have a higher level learning module which is receiving different inputs, like as far as that learning module is concerned, it gets like surfaces, it gets tactile surfaces, it gets visual corners and stuff like that. It gets all of those inputs, and can build models with those and understand the
before we go
commonality
too
across
far,
those.
before we go too far, take this other learning module that's somewhere up the hierarchy.
Yeah.
Is it getting information? On the surface, we would argue that it's getting it, and I'm touching something, or I'm seeing it. Somehow one idea is that the basic feature you're sensing gets passed up the hierarchy, and so they're converging someplace, right? I mean, but then we'd have to understand that, right? We'd have to understand how that happens. How do we pass this information up? How does it become modality independent? That always was weird to me.
It's not that it's modality independent. It's just as long as it's passed up, and let's say there's a learning module it gets tactile features basically, and it gets visual features, and I guess through kind of association, it can predict either one of those.
I'd have to think about how those are going from V1 to V2 to V4 before it gets to someplace higher.
Yeah.
And how's that some basic feature passing through there? The alternate view, which I've never really considered before, but I'm considering more now. Imagine we have a parallel system that says, I'm building morphological models in the world. And I don't care who's telling me there's an edge at this location. And I don't know how this works. I mean, honestly, I don't know how it works. So, but the idea would be, we're not going to go through the hierarchy. We're not going to do the whole processing like we just talked about, which I think is all right. I'm not tossing that away. But maybe there's something else going on. This could be in the wear pathways or something where which tend to be much shallower, by the way. But somehow, it seems to be somehow, I need to build this sort of morphological model that is independent of the sensors that I learned it on or that I'm using at any point in time. It's sort of like somehow I have to go right to location in the world's coordinate system or in my egocentric space. I have to go right to that. I'm starting with that. Somehow I've sensors, doesn't matter what sensor I use, but I go directly to I'm detecting a feature at some location or in space, and it's a morphological feature. It can't tell me what color it is or if it's hot or cold because it's working across modalities. It's just imagine I can take somehow I go right from our sensors. Any sensor can say I'm at this location in world coordinate space. Go into the morphological model, something like that, as opposed to going up the hierarchy. It's sort of like a separate little side thing that is go to direct to morphology. I don't know.
Yeah, I mean,
that's the alternate.
I think that's still an interesting idea to for like a lot of problems also we talked about with voting, but I also agree with Niels that it seems like basic hierarchy can deal with a lot of this multimodal generalization already. So this is something we drew up, I think, during the last brainstorming week, where we have a touch. During learning, we have both touch and vision sensing the cup, like this location on the cup, for example. And in region 2, it learns both the touch and the vision ID at those locations. But then if during inference at some point there's no visual input, only touch input, that should still be enough for this high level column to infer the cup. But since it has learned feedback connections to both of those modalities, it can kind of still make predictions, and you get that kind of mental image in your head of
Wait. How can I have I'm inferring now with vision, right? I'm on the right-hand side.
in this case, you'd be inferring with touch, so the
Oh, I
dashed
see.
lines
Oh.
mean you only had that during learning.
Okay. Dash lines being ahead of during learning. So
Yeah.
I have this R1 vision R2 model. And now I'm touching the thing. R1 touch has no knowledge of the object, right? Never experiences object. How is
That
this
wasn't what this was describing, but I mean, we can.
how does R2 know how to control R1 touch? I don't see that.
So R2, like its representation in L4, it basically cannot distinguish between a tactile feature and a visual feature. In that sense, it's kind of like what you were just describing. It's like, I think you can think of that feature as kind of like a modality agnostic.
Great, but how does it get there? How does it get from, my fingertip to R2? Yeah, the fingertip goes to R1 touch, but R1 touch has no knowledge at all about the object.
Yeah, so I guess it depends. Either it could be a skip connection, or it could be R1 has learned a simple model, like literally just like corners and kind of rims and stuff like that. And that's what it's passing up. And corners
Well,
and
what if
rims
R1 had
and
learned
sharp
R1
edges have visual.
R1 has learned a lot of different things, let's say, but just not this cup. So it would pass up its hypothesis on the objects it knows. It wouldn't pass up, oh, there's an edge at this point. It would say, oh, it could be a soda
I guess I'm
can.
saying it's a simple object. Like the object that it represents is literally like a proto object, like
Right. But let's
like
assume
like an edge rather than a mode.
it's also a very complex object. So wouldn't it try to guess it's one of those complex objects? Because that's how our system works. It would say, oh, I have some feature here. I know 10 objects where this feature could exist. I'm going to pass up my 10 hypotheses as to what object it is. None of those is a proto object. This is the issue I'm trying to get at. It's like when does R1 touch say, oh, I'm sending up a simple proto object versus, oh, I'm setting up all my hypotheses about what complex object I know about. I've learned a lot of things, and
Yeah,
um,
I guess I feel like that would just be like different columns and different, because
Okay.
you'd probably have you probably would have like an R1 column that's recognizing like cylinder or hypothesizing cylinder, and that's also associated with a visual model of
would I, or
structure.
would I have
So, and
ones
that would be more
would,
efficient. That
would
would
I,
enable you to more quickly have this multimodal model.
but I don't think that's true. I think R1 has models of, not just cylinder, but has models of, cans and spray bottles and vases or whatever it has models of. It's, our columns don't have simultaneously, morphological models and non-morphological. Maybe they should.
Yeah, no, so I'm not trying to argue this is a non-morphological model. It's just a simpler morphological model.
But how do we, when do we want to pass up a simple one versus a complex one? That's the problem I'm getting at here.
Okay.
It's like when I'm learning something for the first time with any particular modality sensor. It's as if, what if I'm learning an object through touch and then I'm going to infer it through vision? So I reach into this black box and I'm touching an object. What I build up in my mind is some sort of morphological shape. I can visualize it as I'm going. It's like I'm seeing it and touching it at the same time.
I wouldn't be surprised if you are leveraging models you've learned before. And because, like, again, thinking back to the TVP Olympics we did with this, like, it was hard to be very specific about what we were recognizing when we were touching it. Like, it was quite easy to say, like, okay, yeah, I'm touching a round object, or I'm touching something with like a long part. Like, we almost described the parts of the objects and their relative arrangement, but it was hard to come to, like, I think I had like the lemur, and I could sense that, like, the long tail, I was like, is this a neck or something? Like, I could sense it was like an elongated object, and elongated object in my brain was associated with different things. And I could sense there was kind of something like legs. So I started to get this kind of like fuzzy impression of an animal. But as soon as I opened my eyes, it's like, oh, okay, it's a lemur. It was a much more detailed, specific model.
Right. I guess we're touching on this idea that we have these morphological models, and morphological models can be shared across sensor modalities. Morphological models aren't very detailed. You may not be able to individually quickly, identify the lemur, right? It's just, you got, or it's the heart, that we've been touching earlier, the red helped, for example. So there's sort of, we've gotten to this idea of talking about morphological models in the past. We say, oh, in each column there's a morphological model, and then there's detailed versions of it in the same learning module. Vivian has proposed, but maybe, I'm not sure what she proposed, but anyway, it just seems like the morphological models sort of act a little differently. They are, from the get-go, they are perhaps always learned modality independently from the get-go. That's the first thing I learned. And immediately I can learn what the object feels like or looks like, and I can go back and forth between those two modalities. But it's always only the morphological idea. And then I can learn specific versions of it that require vision or touch.
Yeah, I think morphology models are much more modality agnostic than like features that
Right.
are
And
usually modality specific. I guess one other thing to maybe, I'm not sure exactly what the context was because it's been a while back, but this is something that you presented some time ago, which I think was also related to modality independent recognition, where it could leverage fast learning at the top of the hierarchy that's modality independent, and then inference can use different modalities.
Right, I agree with this, and I still think this is right. But I'm questioning now is I never really understood. This was talking about the slow and the fast learning, and that seems to be absolutely right. But but at the same time, I never really figured out how that green arrow worked. You know, what am I passing up there? It's
Yeah.
clear that, you know, the hippocampus does this, you know, quick learning and, you know, and we don't want to have V1 learn things because it's really a critical resource. So the V1 is going to learn, you know, the most important things. And I've argued like letters will eventually be learned in V1 because we read so much. But other things won't be learned there because it's just not a capacity. So I guess take this diagram. What I'm questioning now is the following. I'm saying, like, is it possible that there's a shortcut to the top of this picture, right? We instead of going up the hierarchy like this, there's a shortcut to get us to the hippocampus that's maybe, or some other high level region like that, that's quick learning and it's morphological. Really, it's just basically morphological, and I don't want to go through the whole hierarchy to get there. It's like I want it to work all right from the get-go, you know, independent of sensor modality, independent of what I'm doing with my elbow or my finger or my, you know, my nose. I am building up this morphological model in space, and at the same time, we'll be doing our hierarchical learning like we already talked about.
It would be kind of nice if if you can build quick almost instantaneous morphological model in the highest region or hippocampus or something, and then that model can activate or send input to the low sensory modality regions. So you kind of get that mental image of like what someone's drawing on your back or what you're touching based on this modality agnostic morphology model.
Right.
Yeah, I was thinking about that as well from the flash inference perspective, is that the image that's shown when you do flash inference only shows up for 100 milliseconds, but it took me a while after that to figure out what I was looking at. It wasn't like at the 100 millisecond mark. It was like some process was happening slower after that.
Right. I think it's a known fact. I think that's right.
Okay. But then when we were doing the sensory motor Olympics, moving my finger quickly across an object allowed me to build up a representation that I could then apply.
Yeah. So this is what we're touching on here, on a very big aspect of the whole theory that we haven't really worked out yet, which is this fast and slow learning. It's about this learning, starting to learn with, you know, you can learn models that are modality independent. The fact that you can, you know, I could show you, you know, like I can have 5 different shaped objects and in a black box, and you touch them, and you quickly kind of, if they're different enough, you could quickly sort of, as you're touching them, you can visualize them, what they would look like, and then I could show you visually, and you'd be able to pick them apart and say which was which. And yet, it's not like that's like even temporary knowledge. Like I wouldn't necessarily remember those 5 objects the next day. You know, I give you another different set of 5 objects. So there's this fast learning, hippocampal learning. It sort of gets right to the top without going through, you know, I don't know if it goes a hierarchy like the picture, or if there's a separate pathway up there.
Yeah.
All I can say is that somehow we're able to do it quite readily. And I feel like our current mechanism for hierarchy is great for detailed compositional structure, but it doesn't seem to work to solve this problem.
Yeah. I guess 2 thoughts. One is, I mean, I haven't looked in this in a long time, but I think that would fit with like hippocampal anatomy, because firstly, obviously it's an ancient structure that exists in mammals with much smaller cortex, not with like a deep visual hierarchy. And also I'm pretty sure there's evidence of, so like, even though it's often described as kind of getting connections from high level visual cortex and stuff like that, I'd be very surprised if it doesn't also get projections from both lower cortex and even kind of direct sensory input.
Well,
maybe.
that would be, that's an interesting question. I mean, that's really interesting. I mean, if you think about if you think about your episodic memory, clearly I can remember very detailed things. I can say, oh, that was that particular coffee, you know, that particular creamer that I used, and it was on this location on the counter this morning. and that's going to require recognition of all the details of the hierarchy. But on the other hand, we have these simple things like I'm just learning the shape of something, and that seems to be hippocampus as well. And that's very undetailed, right? It's just simple. So like you would expect sometimes to have the whole information flow up the hierarchy because you're remembering a complex scene of details. On the other hand, we're pointing out these examples where you can learn something very quickly, which is very just morphological, not detailed.
Yeah, and so that was, I guess, the second point was, I think actually, Vivian, you brought up years ago, kind of earlier in the project, kind of how if we had sort of Gestalt representations higher level in Cortex, that could bias and make inference faster in lower level columns. But to me, that feels similar in flavor to this, where it's kind of like you just see you see a totally unfamiliar object. The first thing you kind of develop is just a representation of its rough shape. And that rough shape might be sufficiently similar to objects you do know about to kind of bias.
Right. It would
what it
certainly
is.
bias. Right.
But like,
I mean-
I just remember distinctly, like, once coming out of the office during my PhD, and like someone across the street had like a thing on their shoulder, and at first it was just like a white thing, and then I was like, oh, it's like a white square. What is that? And then it was like, oh, it's a purse. But like it was just a really weird person, a really weird orientation.
Right.
But the order of like inference definitely started at the most kind of like coarse and abstract. But I always saw the whole object. It was just I didn't know what I was seeing until it had kind of descended the hierarchy almost.
Imagine, here's a really simple example of the voting we're talking about. Imagine I have just two fingers, and and now I can close my eyes. I know where they are relative to each other in a rough sense, and imagine I'm continually sort of defining some sort of, I don't know how yet, but it's defining some sort of bounding box, which these things are, my fingers are representing. And as soon as, and I'm somehow I want to associate this morphological bounding box with specific objects I might know. But it's sort of like saying all I need, even if I just know that my one finger is on the left side of the object, and my other thing's on the right side of the object, it's voting. That's voting with location, right? It's a very simple one. It has nothing to do with the actual specific object. It just says on any object I know, I'm on the left side, and any object that I know, I'm on the right side, and that alone you get you away from bag of features. I'm sorry, but I'm thinking out loud. That's what I'm walking through this idea that somehow that you don't need to know when we're talking about voting in terms of position, like the problem we're trying to solve, that's underlying all this. Maybe it doesn't involve specific objects. It's maybe just all I need to know is I'm on this relative position to whatever object I'm on. I don't need to know it's a can. I don't need to know it's a cup or anything like that. I just need to know if I have an input and I say, okay, I'm sensing a feature. Oh, and I also know that I'm on the left side of the feature or the object, or I'm on the top of the object. That would be sufficient to get away from bag of features. I don't need a lot. I just need to know where I am relative to the overall morphology of the object. That seems like something like that's happening.
I'm not sure I followed everything.
Yeah, me neither.
So are you, sorry, you're saying there could be voting on location on like graph morphology?
Right. I'm a single learning module, and right now, if I just get one sensation, I'm clueless about where I am relative to maybe other people, right? But maybe I don't need to know where other people are. I just need to know where I am relative to some general morphology. And if I'm saying, oh, and it could be pretty crude. I'm on the right side, the bottom corner, upper top, I'm just, any additional information where I am relative to the overall object. And I can't only get that if it takes a bunch of sensors to define the morphology. But once they do, then I don't need to know anything about those other sensors. I'm just, if I could refer to this sort of morphological object and say, oh, I must be on the right side of this morphological object, and someone says I'm on the left side of this morphological object, that's sufficient to solve the voting problem.
Is it maybe one way of describing it is like, rather than a centroid, it's sort of an arrow pointing towards the center.
Or
Kind
maybe I'd rather not. I
Like-
still like try to avoid center. It's sort of.
Is it still relative to the object, or is it in world space?
Well,
or
I guess
common
what
space?
we don't want to do is rely on knowledge of what the object is. We don't want to say, oh, this is a coffee cup, this is a, whatever.
Well, yeah, I guess the main thing I'm worried about with that, which maybe it's fine, but is that it almost becomes equivalent to the learning module just sending its sensory input to a different learning module, or like having pooled different sensory input to one learning module. Like if we're not taking into account the object model,
You
then
are,
that's-
but you're taking into account to the temporarily created morphological model, not the object itself. It's like, it doesn't matter what the object actually is, it's just its shape. And as I have more sensors, I am refining knowledge about the shape. But again, I'm not trying to relate that shape to the specific object. I'm just saying there is a volume in space, the shape of this thing. I'm at some position on that shape. That's sufficient for me to solve my voting problem. So yes, I have to have knowledge of all the sensors have to build up this morphological space, and now I just need to know myself relative to that.
but then the shape, the rough shape, is still a model that's inside that learning module, right?
I'm not sure how it works. I don't know yet. Maybe, but it shouldn't be inside that particular learning module, because remember, I can do this with different sensory modalities. I can do it. It's sort of like, yeah. I don't know how
I
to
guess what I
describe that.
mean is, if we're not taking into account the model at all, it's basically just like taking this green input that's in a common reference frame and just sending that as input to the learning module, which we currently do, but then basically processing it as like a normal input feature. Like as if the learning module gets multiple locations at the same time step.
Yeah, I see. I think I see where you're going, Vivian. I don't have a good answer to that.
Which, I mean, is a solution that would probably work well. I'm just not sure if this is where we want to go.
I don't know. I'm just making some observations. It feels like we are able to build these morphological models that are independent of sensory. They're independent of the sensor. So I can do it with my touch, my vision, my elbow, it doesn't matter. I'm able to build up this sort of morphological structure. I can do it rapidly. I can do it as a episodic type of memory. It's not a permanent thing. And as I do this, I'm sort of filling in points in space where this object exists. And now I'm going to use that somehow to improve my inference. That is, I know where I am relative to that global thing. Maybe you're arguing that yeah, I don't know if it solves the problem. I see you're getting at it. I haven't really solved the problem. I'm just at least breaking it into two parts. I'm trying to say that there's this morphological model that has to be built independently of modality. It has to be built rapidly. It's often just temporary, and I still don't know how it's going to help. I don't know the mechanism by which a learning module would take advantage of this. Maybe that we could only do this for morphological shapes we've learned. So maybe there's a collection of morphological shapes, and then I can always associate those morphological shapes with the specific objects, something like that.
Yeah,
Or
that,
maybe
I guess that's what I was wondering with like, because I feel it's hard to imagine how you would learn this global structure without movement. Like, if you understand what I mean, like it feels easier to understand how you'd vote on something you've previously felt and develop the global structure, even if that global structure is very coarse and is kind of reused.
But I don't understand what you're saying about how would we learn without movement? Right.
Yeah, but if we've kind of learned some more primitive objects, and those
but it
could be, like
seems like
mathematical, like it could be,
all right,
or
so
it doesn't have to be
so
perfect cylinders. It can
so
be kind of,
maybe there's a world of morphology. It's over here. It's shapes that are independent of anything. And then there's a world of specific objects.
and again, it can be kind of on a spectrum. I feel like it's like it's just because hippocampus or associative cortex, whatever it is that's getting this stuff, is getting as you say, like different sensory modalities in and stuff like that. So it's not concerned maybe as much about the specific structure, but it's not a fundamentally different mechanism from how we learn normal morphology models. It just
Maybe.
learns faster.
Well, I guess here's the thing: is if I imagine, okay, I'm a piece of tissue, and I'm going to learn a morphology model, and I'm going to be able to learn it independently of whether you're using touch or vision or your elbow and so on. Then it seems to me that I can't have a sensor module because this individual sensor doesn't really make any difference. I'm going to be getting locations in space just like we do now, but the locations have to come from or somehow independent of the sensor. It's like, yes, I'm getting sensors in space just like we do now, like locations in space. But somehow I skipped all the other baggage. How it is.
Yeah.
What did you think
no.
about the like basically taking the area that models your hand, and then you learn different states of that hand, and depending on what state the hand is in, it biases different objects in like your touch columns.
Yeah, so that's sort of saying, yeah, the words made sense.
But what if you do kind of an unusual state of your hand? Like, I feel like I don't normally grab stuff like this, or I certainly
Yeah.
don't normally grab stuff like this, but like, I still get a sense of kind of the volume.